This is not a story about survival. It is a masterclass in primitive engineering and applied physics. Using only the materials of the forest, she will solve complex structural problems. She will build shelters, tools, and even infrastructure from the ground up. Pay close attention. The techniques you are about to see have been forgotten by the modern world. Phase 1 begins with site selection and excavation. She's not just digging a hole. She's terraforming the landscape to create a stable foundation. Next, she processes timber for a load-bearing entrance portal. This frame will prevent the collapse of the earthen structure above. Each piece is carefully notched to create interlocking joints, a key principle of timber framing. The frame is assembled, providing critical structural support to the entryway. She continues to refine the components for a precise friction-fit assembly. The lintel is set in place, completing the primary entrance structure. Now she sources local stone for the next phase, masonry. She uses a harder stone to shape the softer sedimentary rock. She begins constructing a dry stack retaining wall to stabilize the excavated earth. Wet clay is introduced, acting as a natural mortar or daub to bind the stones. This composite wall of stone and clay has excellent compressive strength. The finished masonry is both structurally sound and aesthetically pleasing. A view from within. The structure is secure and well integrated into the landscape. The initial shelter is complete, a testament to fundamental engineering principles. She immediately begins improving the design, reinforcing the entrance. The masonry work continues, extending the retaining wall for greater stability. The finished structure is a perfect example of semi-subterranean architecture. She uses the clay daub to fill any gaps, creating a weatherproof and insulated wall. The process is slow and methodical, ensuring a high-quality finish. The careful placement of each stone is critical to the wall's overall integrity. The shelter is now significantly more robust and defensible against the elements. She refines the entrance, ensuring a tight seal against the timber frame. A moment of inspection. The engineer reviews her work, planning the next phase. The completed shelter, a masterful integration of natural and built environments. The final cleanup is a crucial part of any construction project. She improves site access by constructing a small stone staircase. The completed project is a fully functional, primitive dwelling. Further site improvements include clearing brush and managing water runoff. The shelter now looks like a permanent fixture of the landscape. The focus shifts from civil engineering to site maintenance. The finished entrance is clean, stable, and well-drained. She takes a moment to admire the completed structure. With the exterior secure, she can now focus on outfitting the interior. The shelter is not just a structure, it is a home. Now she begins work on the roof structure. She secures the main support beams using a metal wire, a modern material for added durability. This creates a rigid frame that will support the roofing material. Next, she harvests bamboo, a key building material prized for its strength-to-weight ratio. The bamboo is transported to the construction site. The bamboo culms are laid across the timber frame to serve as purlins. She processes the bamboo, splitting it into smaller, more flexible pieces for weaving. This is the raw material for creating woven bamboo panels. Using natural cordage, she begins weaving the bamboo strips into a sturdy mat. This woven panel will act as the roof sheeting. The process requires patience and a significant amount of material preparation. The finished panel is hoisted onto the roof structure. She continues to weave more panels to complete the roof covering. The woven bamboo creates a lightweight yet durable weatherproof membrane. The final roofing sections are carefully fitted into place. With the roof complete, the shelter is now fully enclosed and protected. She begins outfitting the interior, starting with a stone and timber hearth for cooking. This raised hearth is a critical safety feature, isolating the fire from the rest of the shelter. She prepares a sleeping platform using a simple wooden frame and soft foliage for insulation. The completed interior is a functional and surprisingly comfortable living space. The shelter is complete. She's created a durable, weatherproof home from scratch. A woven bamboo mat serves as a simple, effective door. She now begins crafting tools, likely a trap for sourcing food. The finished product is a bundle of repaired bamboo, possibly for arrow shafts or snares. The next project, creating a durable, dry floor for the shelter entrance. She processes a log into uniform circular sections. She prepares a bed of wet mud which will act as a leveling compound and adhesive. The mud is smoothed to create a perfectly flat substrate. The log rounds are then set into the mud bed, creating a corduroy floor. This technique distributes weight and keeps the walking surface elevated from the damp ground. The finished floor is both incredibly durable and visually striking. She continues the painstaking process of setting each paver. With the exterior flooring complete, she prepares to move in permanently. She inspects the finished shelter. The hearth is prepared for its first fire. The fire brings life and warmth to the new home. A moment of triumph. The engineer enjoys the fruits of her labor. She continues to improve the shelter's roof, adding more bamboo for better waterproofing. The final result, a complete, self-sufficient homestead built with masterful skill. The shelter's roofing system is being reinforced with additional bamboo purlins. Each piece is carefully woven into the existing structure to increase its density. This multi-layered approach to thatching is key to its weather resistance. The final roof structure is dense, strong, and highly water resistant. The lashing technique uses friction and tension to create strong joints without fasteners. Here we see the intricate detail of the woven bamboo knots. With the exterior complete, the final interior flooring is laid. She begins a landscaping project, sourcing local plants. These plants are strategically placed to help with erosion control and aesthetics. The completed homestead is a perfect fusion of engineering and nature. Inside, she prepares for the evening, enjoying the comfort of her creation. A fire is lit, providing warmth and a means for cooking. The daily work of survival continues with resource gathering. She selects dry, seasoned hardwood for an efficient, long-lasting fire. Large leaves are gathered, likely for use as plates, containers, or additional roofing. Traversing the difficult terrain is a constant logistical challenge. She processes the firewood, cutting it to a usable size for her hearth. The axe is used to split the rounds, increasing the surface area for faster combustion. A smaller knife is used for more detailed carving, likely for making tools or traps. A brief rest. Energy management is a critical survival skill. With her primary shelter established, the engineer's ambition grows. The focus now shifts from simple shelter to more advanced technology. This requires the creation of more sophisticated tools and systems. The next project is not about shelter, but about harnessing energy more efficiently. She begins by designing a system to improve her fire's performance. This will involve principles of thermodynamics and fluid dynamics. The foundation for this new technology is a carefully constructed stone hearth. This hearth is designed to contain heat and direct airflow. The key innovation will be a forced air delivery system. This system, crafted from bamboo, will act as a primitive bellows. By channeling air directly to the base of the fire, she can dramatically increase its temperature and efficiency. This allows for more complete combustion and less smoke. It's a brilliant application of the fire triangle: heat, fuel, and now concentrated oxygen. The successful implementation of this technology is a major leap forward. This high-heat fire can be used for cooking, firing pottery, or even primitive metalworking. She has moved beyond mere survival and into the realm of primitive technology. Her next project is even more ambitious: infrastructure. She will build a bridge to cross the nearby stream. The project begins with the construction of a simple A-frame shelter near the water source. This secondary shelter will serve as a construction camp for the bridge project. The A-frame is a simple, effective design that is quick to erect. The roof is thatched with available leaves for waterproofing. She covers the frame with a tarp-like material, possibly made from woven leaves. The finished A-frame is a small but functional field office. She makes final adjustments, ensuring the structure is stable. A small fire is built to provide warmth and cook meals during the extended project. The fire provides a warm, safe hub for the construction site. She begins constructing a large, stable cooking hearth near the A-frame shelter. This larger hearth allows for more substantial cooking and heat production. The meticulous placement of stones ensures stability and optimal airflow. The finished hearth is a significant upgrade to her camp kitchen. She ventures out to source the primary materials for the bridge. A large, straight log is selected to be the main structural girder. The log is processed on site to reduce its weight for transport. Transporting this massive beam is a major logistical challenge. She uses a clever technique to prepare a bamboo pipe, possibly for the hearth bellows. The internal nodes of the bamboo are cleared out. The finished pipe is now a hollow tube, perfect for directing air. It is integrated into the hearth, completing her high-efficiency stove design. She begins her survey for the bridge site by testing the local clay. The quality of the soil and rock will determine the location of the bridge abutments. She transports the processed clay, which will be used to construct the bridge's foundations. She begins excavating the site for the first abutment. She creates a gravity-fed water delivery system using a bamboo aqueduct. This provides a steady supply of water for mixing mud mortar and for personal use. It's a simple but brilliant piece of hydraulic engineering. She begins constructing the stone foundation for the bridge abutment. This foundation must be strong enough to support the entire weight of the bridge. She gathers dry tinder, preparing a fire at the construction site. The controlled fire provides warmth and a way to cook during the long construction process. She uses large leaves, likely banana leaves, as a clean surface for food preparation. The fire burns steadily in its well-constructed hearth. She processes bamboo for the bridge decking with a handsaw. The primary log girder is maneuvered into position across the stream. This is the most critical and dangerous step of the bridge construction. She begins lashing the decking supports to the main girder. The bridge begins to take shape, a testament to her planning and effort. She continues to add structural elements, increasing the bridge's stability. The finished bridge, a functional piece of civil engineering created from the wild. Now begins the painstaking process of lashing the deck supports to the main girder. These cross members will prevent the bridge from twisting under load. She now harvests and processes a large quantity of bamboo for the decking. The bamboo is split to create flat, wide planks for the walking surface. The prepared bamboo decking is stockpiled at the construction site. The decking is transported to the bridge and prepared for installation. She begins laying the bamboo deck, carefully placing each piece to create a solid surface. Each plank is lashed securely to the cross members below. The dense latticework of bamboo creates a remarkably strong and flexible deck. A final inspection of the joints and lashing before the load test. She tests the bridge's structural integrity with her own weight. The final sections of the deck are laid and secured. The final inspection. The bridge is complete and ready for use. The first crossing. The bridge performs perfectly under load. A moment of quiet satisfaction in the middle of her creation. The bridge successfully connects the two sides of the stream. This piece of infrastructure will dramatically improve her efficiency and safety. She reaches the other side, a look of triumph and pride on her face. The completed bridge stands as a monument to her skill and determination. But the work is never done. She immediately begins sourcing materials for the next project. She begins harvesting bamboo, a versatile and fast-growing resource. The outer layer of the bamboo is stripped away to improve its workability. The processed bamboo is stockpiled, ready for the next construction. A new structure begins over the water, possibly a fishing platform or a shelter. The bamboo framework is lashed together, demonstrating her mastery of this technique. The roof is thatched with bamboo leaves, a quick and effective waterproofing method. With shelter secured, she turns to finding food, foraging for edible greens. Back at the shelter, she makes final improvements to the roof's structural integrity. A fire is started inside the shelter, providing warmth and a way to cook her foraged meal. The finished shelter glows warmly, a beacon of ingenuity in the wild. A very special thank you to the owner of the YouTube channel at Ms. Yang for creating this wonderful video and allowing me to comment. If you enjoyed this narrative, please visit and support their channel at the link in the description below.